Number 1 asks which expression is equivalent to x to the fourth minus 16. X to the fourth minus 16 is just the difference of two perfect squares. I know that because there are two terms, there's a minus sign, and the exponent is even, and this is a perfect square. In this case, you're looking to just factor it. They don't even factor completely. They turn into x squared plus 4 and x squared minus 4, which follows the rules of difference of two perfect squares. Number 2, they want you to find an expression of the fifth degree written with a leading coefficient of 7, a constant of 6. The choice is number 4. When it says fifth degree, you're looking for an expression whose highest exponent is 5. In this case, that satisfies 1 and 4. Well, they want the lead coefficient, so in that case, the leading coefficient, the first coefficient of the expression, should be 7. And the constant is 6. Constant's a number with no variable. In number 3, they're asking you for which interval is the average rate of change is smallest. Now remember, the average rate of change just means to find the slope. So what I did here is for each of these is I did 23 minus 11. That was the difference in the number of households, and I divided it by the difference in years. Same thing for this one. All these are divided by 2 because it's an over of a change of time by 2 years. So I get 12 over 2, 17 over 2, 19 over 2, 14 over 2. This is 6, this is 8.5, this is 9.5, and this is 7. So it looks like this one is going to be the smallest rate of change. So in this case, your answer should be number 1. Okay, number 4, which conclusion can be drawn from the scatter plot? With scatter plots, we're only looking at how things correlate. We are not looking... We can't determine causation. So in number 4, you see how it says buying popcorn causes. You can't determine that from the graph. Generally speaking, because these points go up from left to right, I could draw a line of best fit, and it looks like all these points are trending up from left to right. We're going to say that there's a positive correlation. It's not a negative correlation, and I would say that there is some correlation. So in this case, it's choice number 2. For number 5, this is going to be a system of equations type of problem. I know that there are 150 total tickets, so the number of adults plus the number of children should be equal to 150. Now in this case, they're talking about the amount sold. So now we are going to try to figure out, well, an adult ticket costs $10.25, so that means I'm going to do $10.25 times A, and then I'm going to add that to $7.75 times C. The only difference is that these word problems always tend to leave off the money sign. That's fine. It doesn't change the meaning of the problem. So it looks like in this case your answer should be choice number 1. In number 6, they're asking you which of these which one represents a linear function. A linear function, you're looking for a rate of change that is constant, and what I mean by that is it goes up by the same amount. Okay, so this one's going up by 7, going up by 7, going up by 7. This one's going up by 2, then it's going up by 4, then it's going up by 8, it's going up by 3, then it's going up by 5, and then it's going up by 7. These ones are always changing. So in this case, it's the f of x function, choice number 1. In number 7, they're talking about the acidity in a swimming pool. This is basically kind of an average problem. They're looking for the average, and the first two readings are 7.2 and 7.6. Which value for the third reading will result in an overall rating of normal? Basically, it's saying 7.2 plus 7.6 plus something when divided by 3. This is how we find the average. If we're going to find the average here, which one's going to give you a value between 7 and 7.8? So which of these is going to give you a value between 7.8 and 7.0? Just to demonstrate that it's choice number 2. We are going to get 22.1, and we're going to divide that by 3, and 22.1 divided by comes out to 7.7. This is indeed between 7 and 7.8.